Hey, how's it going, guys? So back again. Here we are, a little bit more vibe coding for Open-FDD. Yesterday, so we were looking at how you can vibe code fault detection in kind of some very generic retro commissioning styled reporting. So like I was kind of curious just to see if I can vibe code a standalone HTML file, which we demoed that basic functionality, even though it's really messy. So kind of proof of concept. And then also on Open-FDD, we went down here into the to the documentation. So like this is where the expression rule cookbook was right here. So this is the rule cookbook, and then the pandas computing library. This is for outside of Open-FDD to use CSV files. So like what I did from which I got from just a person I know is here's a mass amount of CSV files from a building. It's really messy, kind of like the classic data from the building automation system is really not easy to work with. But something AI agents can do is actually process the data, wrangle the data, validate that it's worth doing or worth it can validate that it's you can work with this data to do like a retro commissioning report. So we fed all of this information into AI. So this, like I was explaining on the previous videos, which I apologize for, the sound settings for really low. I think I have that fixed on my microphone now. Um, so hopefully you guys can hear me. Um, so this is where all of like the expression rules are. And then, like pandas, I was saying, like, this is what you would use outside of Open-FDD. Um, AI agents know exactly what to do with the pandas computing library. Um, and also data fusion. This will be built into Open-FDD in time, where when the application is ready, AI agents know exactly what to do with SQL too. So you can do the same thing in SQL as you can with pandas. Pretty much, it's pandas is like Python's analyst framework. So here we are. Okay, so let's continue working with this. So just come over here, pandas, aim the AI agents right to this location, which I'll put a link for in the YouTube show notes. And then just like another thing worth pointing out, um, I demoed this on ChatGPT yesterday just by uploading all of this context right to ChatGPT. But if people are working with Claude or OpenClaw, or I'm using Cursor. So this was just a way to demo. Um, you can use anything. These AI toolings are very generic, and they all kind of do the same thing. So yeah, so that's ChatGPT. I'm gonna demo a Cursor today, but just keep that in mind. You could keep continuing to use ChatGPT. I would recommend using Claude or some kind of an AI IDE. Just just kind of figured out. It's like if you're an analyst already working with Python and pandas, you're probably already working with an AI IDE, which is that's just a development environment for coding. Um, so yeah, just use it. Don't use the ChatGPT upload thing, which I was doing. I just wanted to kind of demo that. And then what I was also doing too is I was serving the web app the dashboard with Python. So you can download Python for Windows, just Google it, and then releases for Windows, and then just go to like whatever's latest and greatest. Um, it's really simple. You just go, it's just like a .exe thing. So you just, yeah, you could just download something like this. And it would just be, in your downloads, just a little .exe, and then click the button on it to add to path. And there's not much to it. So like, yeah, it's just a .exe file to install Python. And then built into the Python language, there is into the standard, into what's built into Python is like there's web app development server, so you can serve HTML files all completely built into it. So if you just install the little .exe file to install Python, which is not much to it, it's really easy, then you can just hit Python. And look, there we go. So we can see that I have Python running here, Python 3.14.2. And then to serve those static files, this is the command right here, which I could chat with AI, and it would be able to run the command for me. So this is Cursor. I think I've demoed this a little bit. People, they just use whatever tool is easiest for you. I've been liking Cursor for quite a few months now, first about 6 months, and it's been working well enough for me that I haven't had the need to try something else. And like what I really like about Cursor is that it's a fork of VS Code. So VS Code was the latest and greatest IDE for coding, interactive development environment for coders before the AI craze. And then Cursor is like a fork of that. So it has everything I know about VS Code built into it, which I like. So that's why I gravitated towards it. And then I also personally like this light mode. So it's just a light mode. There's like different light modes, dark modes, that you can, this is just easy on my eyes. So, okay. So like what I did yesterday, so I put all of these files into just a directory on my desktop. So these were like these plots of the Liberty Building. And then we're working with these files today. This is the dashboard that ChatGPT made. Just all these files here is probably hard to see. So these are just CSV files. And then this is a huge HTML file that AI built. That is the dashboard. So this is what I'm going to be working with Cursor to butter it up a bit, because there's just so much data on it and it was kind of silly looking almost. But I think it kind of has a basic concept of it. So basically, just to recap, is like I bulk downloaded all of this data from an API to get which is really easy to do. Like it was really easy for me to, as the analyst, to bulk download all of this data because they use some kind of data service like an IoT provider. And then I was able to just use Cursor again to create a script that just downloaded all of the CSV data. And then I used Cursor again to kind of butter it up to get to the point where I could do this validation plots. So as soon as I could get Cursor to wrangle the data enough that I could make some plots in Python, and then this is also in the pandas computing library too. I knew if I could get it into here that then I could start doing something with the data at least to start on this journey. Okay, so hopefully that makes sense. So like this is the same folder I had open up just a minute ago in the Windows Explorer. So this is the same, I think I was actually looking at the same plot just a second ago, but I'm just viewing it through Cursor. And then this is the dashboard that ChatGPT built. Okay, maybe I should show you guys this too. So if you want to download, just say download Cursor for Windows, just Google it. Cursor works for me. I'm sure if you want to download Claude, people say, oh, you should download Claude because Claude is better. But whatever. You can use the same models and it works good enough for me. So just feel free to, if anyone needs like any kind of like coaching in any of this, feel free to look me up. I'm a freelance person in this industry. I can help out on an hourly rate. And don't feel bad about needing help. So I hire help all the time. So like I do a little bit of, I'm on the computer all the time, and I do a little bit of game development as a hobby, and I need help in that because it's really hard. Game development in Unity is really tough. So to get me jump started and where I need to go, don't hesitate to hire a coach. So like I do it all the time. So it's no one should feel embarrassed about how do I get started and all this stuff, because it can really expedite how fast you can hit the ground running. People do it with surfing. I think I've even taken surfing lessons. So just reach out if look me up on Discord. There's a Discord channel for Open-FDD as well. That's right in the top of Open-FDD. There's these little icons here. Join the Discord channel. Yeah, don't hesitate in asking for help. Okay, so it looks like my little mouse thing went away, so let's open you back up again. Okay, so like what we want to do today is maybe we should just let's look at this. So like okay, so I did run this command. You can even chat with the agents to run it for you. So this is running on port 8000 locally, so you just go to localhost :8000. And then this would be basically what's going on right now is Python is actually serving all of these files right here. So you can view them you can view all these through the browser if you wanted to. But I want to go right into here, and this is my HTML file. So in Cursor, that is the same thing that is here. So this is the HTML file, and then when it's served through Python, it is this. So this was this like crazy big file. Okay, so I believe these are buttons. Executive summary. So these are buttons here. So I'm gonna ask Cursor agents to really, there's just too much going on here. Okay, so where do we start? There's just like so much to even start with. Okay, so let's I'm almost thinking about like these would be better to be as a separate HTML file and be linked to this. So let's just start here. So this is our prompt that we did to ChatGPT. And I think I might actually just replop this right into Cursor. So like, I'm just gonna do this. Like, this is just a Notepad app in Windows, just in plain old Notepad. So this is what we use for with ChatGPT to make all this. Okay, so let's just do this. So I'm going to be talking to Cursor agents now. So like I used this yesterday to build with ChatGPT a dashboard for RCX and HVAC data, but it needs a lot of help. Okay, look, I'm gonna actually do something here. So I'm gonna put this right into Cursor. Okay, so hopefully you guys can see this. Maybe I should just do this right in here. Doesn't matter where you make the prompt. Maybe I can do one more size bigger. So it's kind of jumble everything a little bit. So, come on. Okay, so this is my prompt. And then this is all that we did from yesterday with ChatGPT. I think it's worth reprompting this to Cursor agents just to show them how we made this. Okay, so look, I used this yesterday to build a ChatGPT dashboard for RCX and HVAC data, but it needs a lot of help. I'm just going to say, drag this right into here. This is what it made, and work with these files. We are trying to make something useful for the client. More than likely, I will ship this to the client and tell them how to run it. And I can even probably copy this too. Okay, so you can copy things from PowerShell right into here too. So like right now, the AI will get the idea that this is the dashboard that we built, how I'm running it and viewing it. I'm just gonna say this goofy carrot things. This is the prompt to ChatGPT yesterday. Carrot over. Probably not that necessary to do that. And then I'm gonna go down here. Shoot, I know if I hit enter that it'll push it all to Cursor agents. So sometimes what I like to do is just give the LLM some kind of a context, like just saying next, like I need this modified so that there is not so much data. It's too much and the charts don't make sense. Color themes are fine, but I would like links to separate HTML files instead of one massive HTML file. Whoops. Okay, so okay, so now I'm just going to start okay, so this is fine. Keep this. So this is just like something showing so I'm just going to tell it to get rid of this. Get rid of this text. Say this is correct. Where then we need to create vaults around this data. This building for context is a VAVHU system with air-cooled chiller, 2 HUs that are variable volume, and it appears, this is what we figured out yesterday, and it appears that there is no data on the VAV boxes for air dampers, positions, reheat coil valves, or airflow set points, which greatly inhibits some of the FDD we can do with these systems. I also want to say what we noticed yesterday too is that the data basically goes back from the tail end of heating season, which was March, and then it goes all the way up to the 4th of July. So we do capture the end of heating season, and we should really have good data on free cooling seasons, and then all the way up to the start of peak cooling season, even capturing June. So June, where this building would be very high humidity outside, and we should have some good. We should basically kind of focus our data analysis around free cooling. So like most of our we're going to be capturing free cooling performance. So I'm just going to say that too. Also the data, the CSV files in here should be geared mostly around free cooling, as I think the data starts around late March and ends 4th of July, and where this building is located, there would I'm going to say located in upper Midwest, there would be high humidity in June, and upper Midwest well below freezing in March, and we would have, and we, I'm going to say, should have captured economizer free cooling season. So please, I'm just going to say this, please gear our report findings around economizer free cooling on the AHUs and reduced mechanical cooling runtimes. And also, we should calculate elapsed equipment runtimes. Let's see, beyond these hours. Beyond these hours. I'm just going to say these hours of operations are from the client, where for their leasing requirements, they need the building to be at set point of 72F during, I'm going to pump in these times again, during these times. It's really redundant what I just did right there, but I think AI will definitely get the picture. So any runtime outside of these windows, we need to calculate elapsed fan motor runtimes in hours for energy savings strategies, for energy savings calcs. Okay, so I hope that makes sense. Like, we can create some analytics for elapsed motor runtimes outside of these hours, if the zone temps are satisfied. So anytime outside of these windows, we need calculated elapsed fan motor runtimes in hours. If zone temperatures are satisfied. I'm going to say ignore if zone temperatures are, I'm just going to say below 70 F or above 75 F. Else we need to be calculating excess fan run times per day in a chart. Okay, so I'm going to ask for a new chart. Executive summary. I think this is garbage. The dashboard executive summary is garbage. Down. Oh, there's too much information here. Okay, so I'm just gonna say feed all of this back into rule setup inventory. Okay, so let's feed all of this back into the AI. Whoa, where'd you go? All right, so I'm just gonna zoom out here so I can copy this. This part of the dashboard is garbage. It's too complicated. And it looks bad. Next section. I always do these little ... things, whether it makes any sense or not. I'm sure that the LLM knows what I'm talking about. Comfort distribution. This next section, the is too complicated. So I think like this chart is a it's a percentage. So I think like, yeah, it doesn't make any sense. I get what it's trying to do. I think it's zone set point performance distribution. And it's gonna say like, what I do like is like it uses Plotly. So like what I mentioned yesterday is like you can zoom in on stuff in these plots, and then you can download them. So like that's the power of doing these dashboards like this. Is it's I think it's as good as Grafana, on a live system. So like you can download and download another picture. So okay, so zone comfort distribution. We need something easier for the maintenance staff to understand, where we should do something basic like percent of time that the floors of the building maintain 72 F. I'm going to say ignore zone temp data in the HU. Just do floor by floor. And then I think this is like trying to do something, and then rank HVAC box base on that, please, for the guess we could do this. I guess this is fine. So it's like it's building a chart for mechanical heating season, worst zone, free cooling seasons, worst zone, and mechanical cooling season, worst zone. Which that's fine, I guess. That could be kind of like a real thing to do too. Is like some parts of the building could have issues during mechanical cooling season, and some could have issues only in heating season, you know, so like that might be nice to know. Oh, it does have a floor comfort zone. Floor, okay, AHU floor comfort. Still doesn't make any sense to me. What the heck am I looking at? I was just gonna say the chart does not make sense. It is too hard. Perhaps some bar chart showing average zone temperatures, zone temps per week, per month would be better. Worst zones, worst ranked zones. Still don't know what the heck this is looking for. Okay, so then like with Plotly, which is nice, is you can zoom in and out in here. So, okay, so like this is 72F. I don't know like what this even is. Chart is not good. I don't even know what it is. I'm gonna say are those zone temps? Okay, weather comparison. I'm just gonna say weather comparison is good. We talked about this yesterday. Boiler heating season outside our lockout. What the boiler heating season outside air lockout is a set point. Remove that, please. I'm going to say this is what we should do too. Please also make a fault rule that compares local outside air temp to web weather data and overlay the fault rule when it is true. So this plot will have local dry bulb, and web dry bulb, and then a fault Boolean flag to see when the comparison of web versus local is true. So like we talked about this yesterday, is that I should say for both AHU1 and 2, or both AHU1 and 2 need separate fault rules compared to the web dry bulb. So we talked about this yesterday, is like a fault rule for local outside air temperature sensor compared to web could be, wow, these are way off. So like in general, like they're kind of close in here, but then at other times they go way out of range. Okay, so let's look at this. So these must be the two local sensors, which seem to track each other pretty well. Seems kind of odd that there's two local sensors on the building. Usually most buildings only have one. And then like what I was thinking a rule would be is to, yeah, these are like within 5 degrees. So something's going on here is that the data from the internet, so this would be the airport weather station, that is yielding, 67 degrees Fahrenheit, 63 degrees, and then these guys are 50. So something's wrong here. Like we could be using economizer free cooling, and then the building is running the boiler system right now because this is actually our enable set point to run the boiler system. So like I'm sure the local building operators may know too, is like they may need to artificially inflate the boiler enable set points, as with chillers too, because their local sensors are just off just enough. So what would be a good flag for this? Maybe within 5 degrees, which is a lot of, so this fault flag, let's set that within 5 degrees tolerance is what we will flag for the local versus web fault on dry bulb sensors. Okay, moving on. I'm just going to say, so this is a probability distribution. Building automation system minus outside air temperature. I don't know, I guess we can keep that. You can keep the histogram, but remove the boiler enable set point. Also, provide a note what the data means. So this is like a probability distribution of the data, normally distributed. So this is kind of nice, I guess, at HU1 trends. So this would be with Plotly. What is cool about this is like we can just individually zoom in on data and then look at our sensors. So this is the power, like I'm saying, the power of hosting a local dashboard with Plotly is then you can download a plot, put it in an email, send it to your client. Okay, so the only thing we don't have, so this is pretty good. It has all of the sensors for supplier temp, mixture temp, returner temp, BAS, outside air temp, supplier fan, chilled water valve percentage. So the trends chart for the needs to include, I've noticed it's include the mixing air damper percent as with the HU2, I'm sure. chart and also include fault overlays as a bool flag on a separate axis. All right, so maybe we'll just look at this next, these fault rules that are flagged. So this is HU2. Okay, same thing with chiller. So I might even ask it to remove the chiller KW power sensors because it looked like it's not even working for one of them. For the chiller, and please include the pump status and fault overlays. Pump statuses for this. Please include pump status and fault overlays. Oh boy, end of heating season analytics. There's just so much stuff here. This is just too much. Okay, so I'm just going to feed this back. Okay, so I'm just going to feed all of this information. Whoops. Just going to say all of this data on the dashboard. It is too much. We need this on different tabs. And it is very confusing, and it should be shortened and put in some sort of a chart. Okay, so like, where else should we go with this? I think we have enough to work with here. We're going to push one massive prompt. Okay, so now we can just say like what we like about this. Like, please keep Plotly. I love Plotly and being able to zoom in and download charts. Make tabs. Make links to other HTML files from a main HTML dashboard. Provide lots of links to make these reporting efforts more organized. And we should like please make nice professional analytical dashboards for each system focused on free cooling efforts. Okay, so like another thing I think we need to say too, I'm gonna get rid of this, is in pandas. So really focus on every temp sensor in the data should have a fault. So this was I think I gave it the wrong link. Temperature sensor out of range. Fault. Await temperature sensor out of fault. And the special custom rule to compare web weather to local. We don't have any. Okay, so we should have this for outside or for air handling unit systems, comparing mixer temp to outside versus return air. For HUs, I don't think yesterday we didn't do a very good job at telling it exactly what fault rules we want. Stale data, no recent samples. I'm gonna do this. Oh, well, let's do flatline sensor. This on all sensors. So this is rate of change. Okay, so air handling unit, let's do this. Please do this for HUs. I think we covered that already. Mixer temp. And this, but remove the heating mode or set constant as permanent 0 because these HUs don't have heating coils. So if you remember, we did get a couple snips from the BAS, which I think is like really important when you do this kind of work, is that you kind of take a once over. This is the only data I have, so I don't have mechanical schedules or drawings, but I can kind of know just enough from here what would be useful. Supplier temp too cold. We can't do that one. Don't have any heating. So okay, so we should do this. So supplier temperature above blend in economizer mode. Try to do some neat economizer diagnostics like this. Outside air temperature too warm. Another one for economizer and mechanical cooling fault. Guess we can include that one too. Whoops. Gosh, we're giving this LLM just a massive thing to do here. And we should probably get some of this too. Oh, we can't do any of these. Okay, we can't do anything on VAV boxes because we don't have zone level data. We can't do anything on these VAVs because we don't have zone level data. There's just different rules, different ways to write economizer diagnostics. Please eval if enough economizer diagnostics has been done. There are more here. I I think the Astra Guideline 36 ones do pretty good. This is just different rules, I guess. Central plant. Okay, so I think the only central plant one is, I'm just going to do this one because it's not a very complicated central plant. It's just a little air-cooled chiller. So for the chiller, I'm going to do a which could indicate low loads and a fault for when we could be using free cooling. Okay, what else can we do? This is just a massive prompt here. I think this is probably good enough. Let me see. So like we also need a chart for elapsed fan motor runtimes per week and in hours, and elapsed motor runtimes per week that are above the, okay, so shoot, I have to go back here, go back into our, so this is from the client. Okay, so elapsed motor runtimes that are above the run hours of the occupied building Monday through Friday, then say if zone temps are satisfied. I'm just going to say this now, please iterate until complete on a revised, gosh, I'm just debating. I think we could just have it just mod all this, I don't care. Revised dashboard, and then test that Python can serve it and there is no errors in the HTML. So like what I mean by that is there's no developer tools, there's no JavaScript errors here. So I'm going somewhere with this is like, okay, so I'm just gonna hit enter here, and then what I have running here, VS Code settings, models. So right at the moment, I'm using Composer 2.5, Opus 4.8, Fable is this famous one the government disabled, and then Sonnet. So these are like very, very smart models. Composer is not as smart as these guys down here, but I'm still using it because I think behind the scenes when we're in auto mode here, so like my cursor instance is just in auto mode. So I think these guys do the orchestrating behind the scenes, and then Composer 2.5 does most of the writing. It writes all the code. And then these guys, I think, are kind of monitoring it. And the reason I still keep Composer 2.5 in there is because it's a really cheap model. So you can get, with a $20 a month subscription to Cursor, you can get a ton of bang for your buck on Composer 2.5. And then all of the reports and YouTubers say it's pretty smart. You know, it's not as smart, but it's good enough. So that's where I'm going with. Maybe some people could just do just Fable and Opus. I think that's a very common one to use. And you get the latest and greatest that AI has to offer that can hack into the Pentagon. But I'm trying to keep costs slim and trim as possible here. So All right, so let's go nuts here. Let's hit this big enter button. Let's see what it does. I feel really confident that on this science experiment, I do like it's doing HTML, which you can build these really cool dashboards. With Plotly, I can zoom through all the data. I feel very confident too that this could even be a process that we can turn into uh, like a specification for software engineering. So like spec driven software engineering. So like once we get all the bugs worked out and what is cool, what is not cool, um, so I'm hoping to do probably 2 more videos after this, and the next video will probably be the final cleanup. So right now, Cursor is going nuts, trying to modify all the code, whatever we ask for, in this massive prompt. And then what I kind of want to get to the point is like to get this to the point where it could be just a generic prompt for one thing, and then to have it more spec driven software engineering, where some people, as long as you're like somewhat of an analyst, you're familiar with R or Python, that you could just plop in some of these spec driven software engineering skills, they call it these days, that you can generate something pretty cool. It'll get you off to the races very fast. And then I think like what I want to do too is like you could even just zip this. You could just zip this and put it on Google Drive or something, send a link to your client, and just being like, download, here's download, unzip it, run it in some form like this, and we can chat over Teams, like what we see in the data. Something like that. You probably could even serve it from the internet if you wanted to, because it's just a read-only dashboard. Let me know if you guys are liking this. What do you think is missing, not missing? And then if anyone wants any specialized coaching, or even for me to do this work for your clients, or whatever, to help you out, I'm also available on an hourly freelance rate. I'm a licensed LLC, so with insurance. So stay tuned for the next video. I'll also try and document how long this will run for, because I don't know. This is kind of a science experiment, so nothing like sticking your neck out on YouTube with a science experiment, but I feel pretty confident that we'll be able to get something pretty cool if these models are smart enough to expose the latest and greatest vulnerabilities in whatever, that it has to be capable of building some generic retro commissioning kind of style dashboard for us. So that's where I'm going. Until the next one, I hope that my sound is okay, and I'll see you on the next go around. Have a great day.